Hello everyone, this is Vishal Dake, Assistant Professor, Electrical Department, Sardar Patel, College of Engineering, Mumbai. In this video, we are going to discuss digital frequency measurement. Content, we are going to discuss point number first, high frequency measurement in more detail. Digital frequency measurement. The basic block diagram for digital frequency measurement. It consists of input signal of unknown frequency, attenuator, Schmitt trigger, AND gate, counter, decoder or display unit, clear or reset pulse, divider, clock oscillator. Now working principle, how it work. In working principle, first I would like to discuss the concept of frequency. What is meant by frequency? Frequency means the number of cycles completed in 1 second. I'll repeat, the number of cycles completed in 1 second. So, if you have any input signal of unknown frequency and we want to measure that number of cycles completed in 1 second. So obviously we require a one signal having a time duration of 1 second. So if we compare the reference signal of time duration 1 second with input signal of unknown frequency by using AND gate, so we could measure the number of cycles completed in 1 second by using AND gate and a counter circuit. So the working principle, how it work. First is clock oscillator. The function of clock oscillator, it produces a train of pulses, a train of square pulses. Then second block is divider. The function of divider is used for select the range of frequency. By using divider, we could set the different range like 1 Hz, 10 Hz, 100 Hz, 1 kHz, 10 kHz and so on. After that, the pulse of 1 second is given to one terminal of an AND gate. Now, the second terminal or second input of AND gate is the input signal of unknown frequency. Now we know that this is sinusoidal signal of unknown frequency. It is connected to attenuator block. What is meant by attenuator? This attenuator is used to reduce the magnitude of input signal. Basically, it converts the high magnitude into low magnitude. This attenuated signal is given to Schmitt trigger. The function of Schmitt trigger is to convert the sinusoidal signal into a square waveform. So here the input of square waveform is given. You can see here the pulse of same frequency as a input. So for AND gate there are two input. One is the reference signal of 1 second time duration and second is the input signal of an unknown frequency. So we know that the function of AND gate, when two inputs are active, that is two inputs are 1 1, at that time output will be 1. So here this AND gate is activated, so it will count the number of cycles within 1 second. So that counter is used to count the number of cycles, and decoder and display unit is used to convert the binary data into decimal form, and display is used to display that. This clear or reset pulse is used to reset the counter after showing the result in the counter. So this is about the block diagram and the working principle of digital frequency measurement. Then waveform. We know that the unknown input signal, this is the unknown input signal. Then second is a reference signal. We know that the time duration of this reference signal is 1 second, because we want to find out the frequency of unknown signal, and the frequency means the number of cycles completed in 1 second. So here is clear pulse. At that signal, at the clear pulse, the counter shows 0 reading. So within 1 second, 4 pulses are produced. It means that the frequency of unknown signal is 4 Hz. We know that one cycle means one positive half cycle and negative half cycle. So this is positive and negative half cycle, positive and negative half cycle. So here the 4 pulses are produced. So counter will count the 4. So 4 means the 4 Hz frequency of unknown signal. Block diagram of digital frequency meter. The main block consists of 1 MHz crystal oscillator, Schmitt trigger, divider, time base selector, Schmitt trigger, gate flip-flop circuit, input signal of unknown frequency, amplifier, Schmitt trigger, AND gate, decimal counter and display unit. So these are the blocks used for measurement of frequency of unknown input signal. Now working principle, how it works. At initial 1 MHz crystal oscillator is used. The function of crystal oscillator is to generate a sinusoidal waveform of 1 MHz frequency. So this is sinusoidal waveform of 1 MHz frequency. It is connected to Schmitt trigger. The function of Schmitt trigger is to convert the sinusoidal waveform into square waveform of same frequency. So this is square waveform. After that, dividers are used. So these are the 6 dividers. The function of these dividers is to divide the time duration of waveform into 6 parts, like 1 microsecond, 10 microsecond, 100, 1 millisecond, 10 millisecond, 100 millisecond, 1 second. Now what is the advantage of this divider? It is used for the accuracy purpose. If you select the appropriate range for the corresponding input signal, then we'll get better result. So that's why the time based selector is used here. So for the accuracy purpose, this divider and time based selector is used in circuit. Then Schmitt trigger is used for the square waveform. Gate flip-flop circuit. What is the function of gate flip-flop circuit? Let's say a reference signal. We know that the frequency means number of cycles completed in 1 second. So to get the 1 second reference signal, we know that one cycle means one positive half cycle and negative half cycle. Like this, in this signal, here is positive and negative half cycle. So it means that this is 1 and 0. So this 0 part is required to convert into 1, because what is the expected reference signal like this. So this is the expected signal. So here this part is required to convert into 1. So flip-flop circuit is used to convert that part into 1. So here we will get 1. So this is the advantage of flip-flop circuit. Now this reference signal is given to one input of a AND gate. Now second input of AND gate is from the input signal of unknown frequency. It is given to amplifier circuit to amplify the signal or to attenuate the signal. It depends on the magnitude of that signal. Then it is given to Schmitt trigger. The function of Schmitt trigger is to convert a sinusoidal waveform into square waveform, and it is given to the another input of AND gate. So the combination when two inputs of AND gate are activated, that is 1 1, then we will get the output of 1. So the counter is connected and display circuit is used to count how much number of cycles are completed in 1 second. So this is the basic working principle of digital frequency meter. Here we'll stop. Thank you.